Good morning students. We are starting today chapter number 13, probability. Before I start probability of 12th standard, I am expecting that you have gone through all the probability of 11th standard because that will give you a smooth understanding here. So with the 12th standard probability, we start with the first definition, conditional probability. What is conditional probability? I am going to explain you, and it is the first very important part which will be used in the remaining part of this chapter. The conditional probability I would like to explain you with the help of one example. Let there are 12 teams which are participating in a cricket tournament. Total number of teams are 12 and India is one of the team. Now I am defining one event. The name of the event is I. Let I is the event that India will be winner. So from the 11th standard, can you tell me if 12 teams are there, then what is the probability that event I will occur? In other words, India will be winner. So I think you all can reply that total outcomes are 12. Any of the team can be winner, and our favorable outcome is only one, and that is when India will win. India will win. So I can say that probability of event I is 1 upon 12 on the basis of 11th standard maths. But I am going ahead with the event with some extra information. This time I am giving you one information that quarter final results are out, and India is one of the team who qualified for semi-final. I named this event Q, repeating again that we have the information this time of the event Q that quarter final results are out and India is one of the team qualified for semi-final. So obviously, can you tell me now what is the probability that India will win? In other words, what is P of I? So I hope all of you know in semi-finals there are 4 teams. So obviously the probability that India will win is 1 upon 4. And from here, see carefully, here also Pi, here also Pi, but the value is changing. Why? Because here I have given you one information, one event which has occurred already, and that event is event Q. So here our way of writing will be, it will be Pi upon Q. This Pi upon Q is the symbol for the event I when event Q has occurred already, and student, this is known as conditional probability. So this is the symbol for conditional probability. So from this discussion, I hope you understood if I am writing Pa upon B, it means probability of A when B has occurred already. On the other hand, if I write PB upon A, it is also a conditional probability. And how will you read it? Probability of B when event A has occurred already. So now, first we come, what is the formula for calculating PA upon B? Details are given in the book. I am just giving you the formula, and the formula is P of A intersection B upon P of B. See, intersection of both the event, probability of intersection of both the event upon probability of the denominator event, that is P of B. In similar way, if I write PB upon A, so you can say it is equal to P of B intersection A. Although they both are same, but in denominator this time we will have P of A. So this is the way, this is the formula which you have to remember. If I further solve this formula, so by 11th standard maths you again know that P of E is equal to N of P upon N of S. So here I can say P of A intersection B is equal to N of A intersection B upon N of S, and P of B is equal to N of B upon N of S. If NS goes, I get the formula N of A intersection B upon N of B. So probability for A upon B is here in the simplified form, that is N of A intersection B upon N of B. So let's understand this formula, implement this formula with the help of a sum, and we have the sum. Here the question is, in a family there are two children. In a family there are two children, what is the probability that both the children are wise? What is the probability that both the children are wise? And the very next statement is, it is given that at least one of them is a boy. It's given that at least one of them is a boy. Try to understand the meaning of the sum. One thing he is asking, find the probability that both the children are wise. The second statement he is telling, it is given that one of them is a boy. So suppose the first event which we have to calculate, whose probability we have to find out, if I name it A, and the event which is given to you, that is at least one of them is a boy, if I name it B, so from discussion whatever we have done, you can realize that we have to calculate here P of A upon B. And just now we learned that P of A upon B is N of A intersection B upon N of B. So if I want to calculate P A upon B, I should know N of A intersection B upon N of B. So let's go for calculating N of A intersection B upon N of B. Whenever you are dealing with such type of sums, you should always start with the sample space. Sample space means, I hope you remember, collection of all possible outcomes. So obviously in that family, either both will be girl, or first one girl, second boy, or boy and girl, or both are boy. It is the sample space. If I talk about my event A is, I have to find out the probability of event A, and that event is that both are boys. So obviously it will be B and B. The given event B says at least one of them is a boy. So please concentrate in the sample space and tell me when are you getting at least one of them boy. I think it is obvious that GB or BG or BB, these three are the event of the given. Now as the formula says, we require A intersection B. So A intersection B means common element in A and B, so obviously it is BB. I am representing here G for girl and B for boy in that family. So now you can say that therefore N of B is equal to how many elements we have here? 3. And in the A intersection B, we have total number of elements, that is 1. So on substituting in the formula, I can say the answer will be 1 upon 3. Value of N A intersection B is 1, value of N of B is 3. So I can say P A upon B is 1 by 3, and it is your answer. With this concept, whatever I discussed, I hope you will attempt all the sums of exercise 13.1 from NCERT. Let's go for a little different case where concepts are almost same, but our way of working is a little different. Just now we learned the formula P of A intersection B, that is equal to P of A intersection B upon P of B. Students, here I calculated PA upon B, but there are many cases where it is easy to calculate PA upon B, it is easy to calculate P of B, but we require to calculate P of A intersection B. P of A intersection B means probability that event A and B both occurs. So let us discuss this type of case. We are modifying the formula by cross multiplication. I can say that P of A intersection B is equal to P of B into P of A upon B. The same formula but with a little different way. P of A intersection B is equal to P of B into PA upon B. Here we are assuming B is down means event B occurred first, then A occurred. So I can say P of A intersection B is equal to probability of first event into probability of second when first has occurred already. So this is the formula. If event A occurs first, it doesn't make much difference, only your symbols will change. If event A occurred first, then in similar way you have to say it is equal to P of A first event into second event, that is B, when first event has occurred already, means when A has occurred already. So we are now working on this formula. So let's understand when it is required with the help of a sum. So the question is, 3 cards are drawn from pack of card one after other without replacement. Repeating again, 3 cards are drawn from the pack of card one after other without replacement. Then what is the probability that first is king, second is king and third is queen? So how to solve? Here in the solution I am assuming let K be the event. First statement will be let K be event of getting a king from pack of card, and similarly I can say let Q be event of getting a queen from the pack of card. So what he is asking, he is telling we want one king, then the second one again king, and third one queen. King and queen, king and queen, and means you know very well intersection. So I can say I have to find out first one is king, means first event K should occur, and means intersection. I want again king means I want again event K, and then I want queen means I want event Q. So I have to find out K intersection Q, and with the help of formula what I have discussed just now, I hope you remember, that is known as multiplication formula. I can say it is equal to P of K, probability of getting first king, into probability of getting second king. Be careful when I am telling second king, here is the alert that the first card was king, so here you have to write K upon K. Please remember, it's not a mathematical expression, it is telling the probability of getting second card as king when the first drawn is already a king. And third event I want event Q, probability of getting queen, but here is again alert of conditional probability that first one was king and second one was also king. Try to understand. Q upon KK means probability of queen when first was king as well as second card was also king. So now just use your common sense. From the pack of card, probability of getting first king. So you know there are 4 kings. So my event can occur in 4 ways, while the total number of outcomes are 52. So 4 upon 52. Now the second part, probability of second king when the first card drawn was a king. So as first card is already drawn, which is a king, so now total number of kings are 3 and total number of outcome, as you know, one card is drawn, so from 52 one card went, so we are left with 51 card. So here will come 3 upon 51. And third, probability of queen when 2 cards are already drawn. Students, you remember the 2 cards which is drawn, they both are king. So obviously total number of queens are still 4. So favorable outcomes are 4 and total outcomes as 2 cards are drawn. So 52 minus 2, now 50 are the total outcomes. If you multiply it, you are getting the answer. The calculation is for you. I'm just writing the answer, that is 2 upon 5525. You can calculate it and check. So first, after knowing the conditional probability, we are starting those events which are totally different from those events. The name of the event is independent events. So first you should know what is independent event before we start. Whenever there are 2 events in such a way that occurrence of one is not making any change for the second one. What I mean, I give you one example. From a pack of card, a card is drawn. After seeing, we kept it again, we have replaced that card and we are drawing the second card again. Now don't you think the draw of the second card is totally free from the first card, as once we have replaced, we are again getting all the 52 cards. So such type of examples are example of independent events. And other independent events, 2 or 3 students are solving the sum independently. So it depends. If A knows, A will solve. If B knows, B will solve. Unlike conditional event, we can't say keep A solve then B cannot, or B solve then A cannot. So such type of events are called independent event. And in that type of case, we have to modify our formula. I hope you remember last time we discussed that P A upon B is equal to P of A intersection B upon P of B. Now students, if we assume that they are independent event, don't you think that there will be no difference on A even on the occurrence of B? What I mean, A is totally free from B, so we have to modify this symbol, as A is not depending on B. So I can say it is same like P of A. There is no role of B whether B has occurred or B has not occurred. So if I modify in this way, now our formula will turn to P of A is equal to P of A intersection B upon P of B. If I cross multiply, then I get P of A intersection B is equal to PA into PB. It is the formula for independent event. Whenever 2 events are independent, then remember this formula, I for independent. So P of what formula you have to use? P of A intersection B is equal to PA into PB. Remember, I for independent, I for intersection and I for into. Means in independent event, you have to take intersection and you have to do their multiplications. You have to do their into. For time being, you remember whatever I am talking, it is for independent event only. Later on, we are going again for the conditional event. So you must know what is the difference in both of them. So for time being, I am just going for independent event and we are understanding it in a better way with the help of a sum. Here we have a question that 3 students are attempting a question. The probability that student 1 can attempt it, one important thing, it is given that they are trying it independently, and the probability that 1 is attempting is say 1 by 2. Probability that student 2 is attempting is say 1 by 3, and probability that third student will attempt that is probability is 1 by 4. Now we have to find out number one, we have to find out what is the probability I'm taking 3 parts and you have to calculate all parts, so you will get a good practice for independent event. Number 1, what is the probability that all 3 attempt the sum? All 3 attempt the sum. All 3 attempt complete the sum, you can say. I modify it. What is the probability that all 3 solve the sum? Obviously they all are attempting, to all 3 solve the sum. Now here I have to find out the probability in mathematics. I can say that student number 1, he solved, and means intersection. Student number 2 solved, and student number 3 solved the sum. So I can say, just for independent event, we learn the formula. It is equal to P of first event into probability of second event into probability of third event. So I can say it is equal to 1 by 2 into 1 by 3 into 1 by 4. If I multiply, I get 1 upon 24. This is the sum which is based on independent event. I am repeating again. Now let's come for the second part of the sum. What is the probability? Try to understand. Here I calculated what is the probability that all 3 solved. Now in second part, I am telling what is the probability that sum is solved. This question is already asked in the board exam, so please try to listen carefully. When I am telling sum is solved, it can be solved in many ways. Might be A solved, might be B alone solved, might be C alone solved, might be A and B solved, B and C, C and A, or might be all solve the sum. So in such cases, I hope you try to recollect your 11th standard maths. When our cases are many, then we go for the concept of complement of an event. What is the complement? I hope you are able to recollect. You will say, let E is the event that sum is solved. For calculating this, I have many cases, so obviously I am going for complement. Therefore, E complement is complement of this event. By 10th and 11th maths, you can say that sum is no one solved the sum. So we are going to calculate here P complement, and from there we will go to P of P. So P of P complement means no one solved the sum. Means I can say first student did not solve the sum and second did not solve the sum. Not solve the sum means complement, and third did not solve the sum. The complement of 1 and 2 and 3 by multiplication theorem for independent event, I can say it is equal to 1 complement into 2 complement into 3 complement. That is equal to, if I substitute the value, I get P complement is equal to PA complement means complement of this means 1 minus 1 by 2, complement of 2 means 1 minus 1 by 3, complement of 3 is 1 minus 1 by 4. You solve it. On solving, you are getting 1 by 4. And you know we have to find out its complement. So your last step will be, therefore probability of event E, sum is solved means at least one of them solve the sum. Its probability is equal to 1 minus P complement. That is equal to 1 minus 1 upon 4, that is equal to 3 upon 4. So answer is 3 upon 4. And if I add one more statement here for the same sum, if I ask you, it is also asked in the board exam, that what is the probability that exactly 2 of them solve the sum. Exactly 2 of them solve the sum means, if I name the event as A, so see there student do the common mistake. Exactly 2, it doesn't mean ki you say student 1 solved and 2 solved, or 2 solved and 3 solved, or 3 solved and student number 1 solved. Here you have to ensure when 1 and 2 are solving the sum, same time 3 could not solve the sum. Here third and second student solved, so I have to ensure that first one did not solve the sum. Here when first and third did, then second one could not solve the sum. Then again by multiplication theorem of independent event, I can say it is equal to P of 1 into P of 2 into P of 3 complement. In this way you have to break all the parts, you have to substitute the value, and you have to get the answer. That work is for your homework. I hope now, based on this concept, you will able to do exercise number 13.2 and 13.3. So now we are going for one very important concept, and that is Wey's theorem. It is a little complicated, so you have to be careful. Instead of writing direct formula for Wey's theorem, better we understand it with the help of a sum. We are considering here two bags. Bag 1 contains 4 red and 4 black balls. Bag 2 contains 2 red and 6 black balls. Suppose say we take 6. So I am denoting it bag number 1, it is bag number 2. And now first I am just asking you something which is revision of what you have done so far. The first question is, if I ask you there are 2 bags and I have to select one of the bag, then what is the probability that I will select bag number 1? So I hope obviously with the concept of 10th maths only you can say, as we have 2 choices while the favorable outcome is 1, so probability of selecting bag number 1 is half. If I ask you what is probability that I have selected bag number 2, again your answer will be half. Let's come what I discussed just now. If I ask you, I have selected bag number 1, now what is the probability of getting red ball? Try to understand. I am telling I have selected bag number 1 means this event has occurred already. You know, in conditional probability the event which occurred is written in denominator, and I want what is the probability of getting red ball. So repeating, probability of getting red ball when bag number 1 is selected, I don't think it's simple. Just by common sense you can say there are 4 balls red which are favoring you, and the total possible outcomes are 4 plus 4, 8. So P of R upon 1 is 4 upon 8. In similar way, if I ask you, if I have selected bag number 2, then what is the probability of getting red ball? So in similar way, I have selected bag number 2 means it is given. Now probability of red ball, again we are very clear that in bag number 2 we have 2 red balls and the total number of balls are 8. So far it is easy to calculate. And now listen about one event. If I am asking you there are 2 bags, I have taken one of the bag, I am not telling you which bag, and I picked a ball from that, and it is known that the ball is of red color. Try to understand. I told there are 2 bags, I have selected one bag, I have not told you which bag. I am just telling you the final output that I got the red ball, and I am asking you now, I got the red ball means R is given, and I am asking you now what is the probability that the red ball came from bag number 1. So when I am telling bag number 1, it will be P of 1 upon R. So this P1 upon R tells probability of selecting bag number 1 when the final output is given to us already, that is we got a red color ball. So this is given and he is asking to calculate something for which we have to go reverse. And students, as we are moving back, we are going back. Therefore, this type of probability is known as reverse probability, and we calculate it with the help of Bayes' theorem. Now, what is Bayes' theorem? This theorem's derivation is given in the book. I am just telling you what is the formula of Bayes' theorem and how to implement it. So, here in the given sum, I can say that I have to find out P probability of 1 upon R. So instead of telling you the formula, better I tell you how to learn the formula. It is the thing to be calculated is 1 upon R. You reverse it, so it turns to P of R upon 1. And upon 1 है तो balancing के लिए into 1. So formula numerator says if it is 1 upon R, you have to write R upon 1, and upon में 1 है तो you have to multiply with P of 1. But on the denominator, whatever I am writing, first I am writing, then you think how I have done. The way I am telling you, so you can write the formula without learning it. Just by thinking, you can tell me. You see denominator, where I have written P of 1 into P of R upon 1 plus P of 2 into P R upon 2. Here I have described how I got the red ball in the final output. Might be कि first I have selected bag number 1 and I got red ball. Plus means in probability it is R. Might be I have selected bag number 2 and I got the red ball. So this is the formula for Bayes' theorem. In denominator, you have to just describe how you got the final output as I have written here. So now the only thing, you have to substitute the value. P of 1 is 1 upon 2, P of R upon 1 we have calculated here already, 1 by 8, and in denominator we have to write P of 1 1 by 2 into P of R by 1 is 4 by 8 plus P of 2 is again 1 by 2, P of R upon 2 is 2 by 8, and to simplify it and get the answer, that is your work. I suggest you normally you can cancel the denominator and the calculation will be very easy. So you can complete the sum in this way. Now before I complete it, I am just asking you, and it is for your practice so that you will be more comfortable with Bayes' theorem. If I am telling, in the same case, suppose I got the black ball. Now what is the probability? If I am asking you that the ball drawn in the output is black, what is the probability that I have selected bag number 2? So what I want, you just get a revision of formula how to do. As I told you, 2 upon B is opposite is B upon 2. Upon 2, so we have to write in into 2. Then I told you in denominator you have to describe how you got the black ball. There are 2 bags, one of the bag you have selected, you got black ball, so you have to describe the event. That might be we have selected bag number 1 and we got the black ball when bag number 1 is selected. Or might be we have selected bag number 2 and we got the black ball when bag number 2 is selected. And in this way, you know how to calculate, find these values. You have to just substitute these values and you will get the answer. So again, I am giving you it for homework, and your exercise 13.3 is entirely on the Bayes' theorem. I hope you will attempt this exercise and then we will go ahead. In the last part of probability, what we are learning today, number 1, what is probability distribution of a random variable? I am going to explain all the words gradually. Probability distribution of a random variable. In the second part, we will learn how to find mean, variance and standard deviation of random variable. So first we start what is random variable, what is probability distributions of random variable. So you can understand, suppose in an experiment I want a particular event. My interest is for a particular event and I want to know 2 things. Number 1 thing, that how many times in that overall experiment where we are taking many trials, how many times my event can occur. Number one, how many times my event can occur. And number two, same time I want what are the possibilities of all those times. Suppose I get my event one time, then what is the probability of that? If it's two times, then what is the probability of that? So if I write these details in a tabular form, then it is known as probability distribution. Let's understand with the help of a sum. Here, if suppose some event can occur by one time, two times, or it might be occur three times, then these all possible times are denoted by a variable. The name of this variable is random variable, and it is denoted by X, capital X letter. So let's understand it with the help of a sum. Here we have a question that if we toss a coin three times, then write the probability distributions for number of heads. When I am writing PD means probability distributions for number of heads when we toss a coin three times. So students, as you know, when we toss a coin three times, here I want to know my event is number of heads. So how will we start? I am interested for number of heads. So first I will declare my random variable. Your starting will be, let capital X be a random variable denoting number of heads. So I hope it is clear. If X is denoting number of heads, so in three toss, how many number of heads I can get? Might be I will get head, no time I will get head, or might be I can get head one time out of the three toss, or might be two times. So far, or might be all the three times I am getting head. So these are the possibilities for getting number of heads, which I have denoted by the random variable X. Now let's calculate all the corresponding probability. So I think we will write the sample space. Our work will be very smooth. In tossing of three coin, our outcomes can be HHH, HHT, HTH, THH, then HTT, THT, TTH, and TTT. You can count the total number of outcomes are 8. Now what is the probability that I am getting 0 time head? You see that out of the all possible 8 outcomes, our favorable event is only one, because only one time I am not getting any of the head. So I can say probability is 1 by 8. Similarly, you can solve for one head. There are 3 outcomes which are giving one head. Probability of getting 2 times 2 heads. So you can count again. Here again we have 1, 2, 3. 3 times we are getting 2 heads. And probability of getting all the 3 heads is 1 upon 8. Only one time I am getting all the heads. So here for X is equal to 3, I am putting 1 upon 8. And students, it's known as probability distribution of random variable X. Let's go ahead. As I told you, I will tell you how to find mean of variable X. Let me repeat, when I am telling mean of the random variable X, it is known as mean also. We say it expectation of X also, both are same. So normally for finding the mean of random variable X, we use the symbol EX, E for expectation of the random variable, and you note the formula is summation Pi into Xi. For calculating it, the formula is summation Pi into Xi. So for better understanding, for here I can say the random mean of the random variable is P into X means 1 by 8 into 0. Then next probability into corresponding X. So 3 by 8 into 1. Then 3 by 8 into 2. Then 1 by 8 into 3. Once you calculate this, you get the expectations of the random variable. So here we get it is 0. So 3 plus 6, 9, 9 plus 3, 12, 12 upon 8, that is equal to 3 upon 2. The value of the EX is 3 upon 2. It is the expectation of the random variable. Now the second part, if you have to find out variance, so write the formula for variance. The formula is summation pi into xi square minus summation pi into xi the whole square. Please try to understand, when you are telling pi into xi square means probability into square of the random variable. So I can say it will be equal to 0 square into 1 by 8 plus 1 square into 3 by 8 plus 2 square, xi square is 2 square into 3 by 8, then 3 square into 1 by 8. And you have to calculate, that work is for you, and whatever value you got from here, that is let me finish this one part, is pi xi square minus pi xi we just calculated, that is 3 upon 2. So minus 3 upon 2 the whole square. Calculate the value, you will get variance. And once you take, the last step is how to find standard deviations. So once you take square root of variance, you will get standard deviation of random variable. Let's understand for more practice with the help of one more sum. The question is here that two cards are drawn simultaneously without replacement from the pack of card. Then find the mean, variance and standard deviations for number of kings. So as we have discussed, for finding mean, variance, standard deviation, we require probability distribution table first, and from there we will use that for finding these all, as I discussed you just now. So your starting will be, as I draw two cards from the pack of card. So it is obvious, the first thing, denoting random variable, let capital X be random variable denoting number of heads, denoting number of kings, because here you have to find your mean, standard deviation, variance for kings, so number of king. Now student, think, if you draw the two cards from the pack of card, obviously then your number of kings can be either 0, or 1, or 2. So I can say random variable will have value 0, 1 and 2. And now we have to calculate probability corresponding to each of them. So let's calculate. The calculation of probability is a little where we have to exercise more, so I am doing it here separately. Probability of getting 0 king. If I am telling I could not get any of the king from those two cards, it means I am getting both of the cards as non-king. So first thing, you know, whenever you draw two cards, the total outcomes are 52C2, and I am getting both non-kings, so it can be obtained in 48C2. If there are 4 kings, obviously 48 non-kings. If I go for P of X is equal to 1, it means I am getting 1 king and 1 non-king. So 1 king can be obtained in 4C one way, while 1 non-king can come from 48C one ways. You have done it in 11th standard also. I want 1 king and means into 1 non-king upon the same 52C2. When I go for P of x is equal to 2, this time I am getting one king. Both are the kings, so obviously there are 4 kings. So from there I can get 2 kings in 4c2 ways upon 52c2. Substitute these all values and approach in the same way. I am just writing the data, but it's your work to implement on that. When you will solve it, you will get here 188 upon 221. Then you will get 32 upon 221. Then you will get 2 upon 221. Now, as I told you, you have to calculate Ex by formula PIXI. Again, you do this into this plus this into this plus this into this. That calculation I am leaving for you. You will get the answer 34 upon 221. When you will go for variance of x, you know in variance you have to calculate first summation pi into xi square minus pi into xi. Pi into xi just now we calculated. Pi into xi square means this into 0 square plus this into 1 square plus this into 2 square. So that calculation is same as we have done just now. So you have to remember this time you will get 36 upon 221 and PIXI you just got 34 upon 221. This calculation part I am leaving you. I am just giving you answers so you can confirm it. After solving you will get 6800 upon 221 the whole square. And it is the value of your variance. And the last one, which is very easy, standard deviations for your random variable x. As I told you, it is nothing but square root of variance, that is square root of 6800 upon 221 the whole square. When you will calculate, it will come 0.37. And now I hope your exercise 13.4 is based on these sums. You will complete it. Now in the end of this chapter, let's come for the last part. If I am asking you, suppose I toss a coin 10 times. If I toss a coin 10 times and I want to know what is the probability of getting exactly 6 heads. I want to know what is the probability of getting exactly 6 heads. So students, it's not easy work, because you know by 11th standard maths, once we toss a coin 10 times, then the total number of elements in the sample space will be equal to 2 raised to 10, that is equal to 1024. So to write 1024 results and to find from that how many times I am getting 6 heads, is really very tedious and time consuming. So in such type of cases, we are going with a different concept, and that concept is known as binomial distribution, what we are discussing today. Binomial distribution will help us and it will tell how to work in these type of sums. But there are certain constants which you have to remember. I am giving you binomial distributions, a formula based on binomial distribution, but please remember, you should apply only is it when all tiles are independent. Like when you are tossing the coin, each result is independent from the earlier head came or tail came, it has no meaning with the next tile. And before telling you formula, I think it is better I give you a sum and from there I explain you formula so you can get better understanding. So we discuss the same thing what I asked in the beginning today. If we toss a coin 10 times, then what is the probability of getting exactly 10 heads, exactly 6 heads? If we toss a coin 10 times, then what is the probability of getting exactly 6 heads? So I am dividing the board in 2 parts. Here I will write some symbol and here I will write what is the meaning of those symbol in the given sum. So in formula, the first symbol I require, that is n. N means number of trials, total number of trials. For the given sum, here you know I was tossing a coin 10 times, so I can say n is equal to 10. Now the second symbol R, you look here that our interest is for number of heads and I want 6 heads. So R means number of times. Here we divide the sum every tile in 2 parts. Whatever we want, that is known as success, and whatever we don't want, that is known as failure. So here R means how many times I want success out of the 10 tiles. So R means number of success. So as you know, here our interest is for number of heads, so R will be here. We want 6 times heads, means 6 times success, so R will be 6. The next symbol is P. P is probability of getting success in one trial. Probability of getting success in one trial. So here, you know, once I toss a coin, one tile means if I toss a coin one time only, then what is the probability of my success? My success is to get head, and students, probability of getting head in one tile will be 1 upon 2. Next symbol is Q, which tells probability of failure in one trial again. So you know, if I am not getting success, means it's the failure case. So probability of failure in one trial. So here Q means probability of getting not head in one trial. Obviously, if probability of getting head is 1 by 2, so not head is also 1 by 2. Here you please remember that P plus Q will be equal to 1, because either I will get success or I will not get success. So now I am writing the final formula. Now after understanding this symbol, formula tells that probability of getting R times success, I am denoting it by random variable x. The probability of getting R times success is equal to NCR, P raised to R and Q raised to N minus R. Now as you know meaning of all the symbols, so I hope we can do the work on this formula. So let's continue the sum here. So this time I want 6 times heads, so x is equal to 6. That is R is equal to 6. I have total number of tiles are 10, so N will be 10. We have R is 6. We have probability of success is 1 by 2, 1 by 2 raised to R. R is 6 here. And Q means probability of failure, that is again given to you 1 by 2 raised to N minus R, that is 10 minus 6, that is 4. So if you will solve it, it will come 10C6 and 1 by 2 raised to total power 10, then you can calculate it further. So here in this way we have used the concept of binomial distributions. If I ask the last part in the same regard, if I want to know in the same throw of tosses, in the same toss of 10 coins, if I want number of heads at least 7 times, I want at least 7 heads. So now the probability I can calculate in this way. I want at least 7 means I want x 7 or more than 7. It means 7 will do, 8 will also do, or x can be 9, or x can be 10. I want to just discuss the concept because I hope ki calculation part you can do. For 7 it will come 10 tiles will say I want 7 times success, 10C7, and if you will solve it as you solved earlier, it will come 1 by 2 raised to 10. In same way, 10C8 into 1 by 2 raised to 10 plus 10C9 into 1 by 2 raised to 10 plus 10C10 into 1 by 2 raised to 10. The way is same as we have discussed just now. You can solve it and you will get the answer. Now on basis of this, we have the exercise 14.5. I hope you will complete the exercise 14.5, and that is the end of the chapter probability. Thank you very much.